This is a recast of the 1600-word piece, The Characteristics, Orogens, and Geodynamic Settings of Supergiant Gold Metallogenic Provinces, from academia.edu. Let's listen in.
Today's focus is the characteristics, origins, and geodynamic settings of supergiant gold metallogenic provinces. The paper discusses 6 unique classes of gold deposits. The first is orogenic gold, followed by Carlin and Carlin-like gold deposits, epithermal gold-silver deposits, copper-gold porphyry deposits, iron oxide copper-gold deposits, and finally, gold-rich volcanic-hosted massive sulfide to sedimentary exhalative deposits.
The classification of these deposit classes is based on a variety of factors including ore and alteration mineral assemblages, ore fluid pressures, crustal depth or depth ranges of formation, relationship to structural and magmatic intrusions at different scales, and the relationship to the petite evolution of the host terrain.
Each class of deposits is generated in distinct geodynamic settings. For instance, orogenic gold deposits are generated at mid-crustal levels, close to terrain boundaries in transpressional subduction accretion complexes of Cordilleran-style orogenic belts.
That's accurate. On the other hand, Carlin and Carlin-like gold deposits develop at shallow crustal levels in extensional convergent margin continental arcs, while epithermal gold and copper-gold porphyry deposits are formed at shallow crustal levels in continental margin or intraoceanic arcs.
Iron oxide copper-gold deposits form at mid to shallow crustal levels associated with extensional intracratonic and orogenic magmatism. Gold-rich VMS deposits, however, are hydrothermal accumulations on or near the seafloor in continental or intraoceanic back arcs.
Quite fascinating. There's also an interesting point about how the tectonics and geodynamics play a role. It seems like the compressional tectonics of orogenic gold deposits is generated by terrain accretion, with high heat flow stemming from crustal thickening.
Indeed, the extensional settings of Carlin, epithermal, and copper-gold porphyry deposits result from slab rollback driven by negative buoyancy of the subducting plate. Therefore, it's safe to say that geodynamics play a critical role in the generation and positioning of these gold deposits.
This article presents a wealth of information about the geodynamic settings that influence the formation of different types of gold deposits. It highlights how these environments create varied conditions that lead to distinct classes of gold formations.
That's it for today.
My name is Ricardo Valls. I am a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.